In this lesson, we're going to cover the first part of dilations and scale factor. When we're talking about dilation, we're talking about the transformation that changes the size but not the shape of the figure. So dilation has to do with getting bigger or smaller. So we would say that all three of these stars, depending on which one is the original image, have been dilated. The center of dilation is when you have two figures here, and when you have them that they've been dilated, the point of intersection of the lines connecting each point on the pre-image with its corresponding point on the image. So for example, here our pre-image is A, B, C, D, and our dilated image is A, B, C, D prime right here. So if we were to connect all of these lines, we connect B with a ruler and connect C, D, and A. We notice they all converge here at point P. Okay, so we would call that the center of dilation. Scale factor is when you have a dilated image, and it's the amount that the image has been either expanded or contracted, meaning either bigger or smaller. Okay, it's the ratio of the length of the side on the image to the length of its corresponding side on the pre-image. So for example, this triangle has been reduced by a scale factor of 1/2. That means each side has been reduced by 1/2. So this side right here, okay, this side is 1/2 of this side. And this side is 1/2 of this side. And this side is 1/2 of this side. So when we have scale factor, when we're talking about scale factor, we have two things. Expansion, that's when the image is enlarged, it gets bigger, and that means that it has an absolute value of greater than 1. Okay, so remember the absolute value is when if we were going to take the positive of a number. A contraction is when the image shrinks. Okay, so that means when it gets smaller, and it's going to have an absolute value of less than 1. Okay, so when we're talking about a image getting bigger or smaller, we always want to talk about the positive side. So for example, 5/4, 1.5, in this one, if it's -4/3, the scale factor we would apply would be 4/3. You don't have to worry about the negative. So it's -4/3, if it's positive, is actually bigger than 1. Okay, so that's where you don't want to get confused with negative numbers, right? Because -4/3 is actually less than 1 if we were just going to talk about -4/3. But in the sense of if it's positive, +4/3 is bigger than 1, right? Because that would be 1 1/3. All right. Same thing over here. -3/4. Okay, it's both here, right? I mean, that's less than 1, but even if it's a +3/4, it's still less than 1. So that would be a contraction, it would shrink. So with scale factors, okay, positive numbers, the image is on the same side of the center of dilation as the pre-image, okay? So that means if you have a positive scale factor, right, and let's say I have this triangle, and then my center of dilation is right here, okay? If it's a positive scale factor, that means that my image is going to be on the same side. Okay, see how these two are on the same side of C? If it's a negative number, and say my center of dilation is right there, okay, then that means that my image could end up on the opposite side of the center of dilation. Okay? So here's a few examples. We want to circle all the ratios that would result in an expansion, okay, so bigger. So that means we're looking for numbers that have an absolute value of greater than 1, okay? So here we have 7/9, okay, that's less than 1, so we would include that. 5/4, okay, that's 1 1/4, so that's going to be okay. 1.5, okay, that's bigger, obviously, than 1, so we would include that. 3.4, that's bigger, so we'll include that. 1.001, even though not much, it is bigger, so that would be an expansion. 4/5, that's less than 1, so we would not include that. 2/3, that's less than 1, so we wouldn't include that. 0.25, that's 1/4, which is less than 1. 9/8, okay, that's 1 1/8, so we would include that. negative 3/4. Now we want to look at it in the positive sense, okay? So if we were to take this and make it a positive 3/4, it's still less than 1, so we wouldn't include that. 0.1, that's less than 1, so that would not be a larger one. And then negative 4/3. If we were to make this positive, that would be a positive 4/3, which is greater than 1, so that actually would be included. So here, we want to circle all the ratios that would result in a contraction, okay? So that are getting smaller, all right? So 7/9, that's less than 1, so we would include that. 5/4, that's bigger, so we wouldn't with that one. 1.5, that's greater, so that one's a no. 3.4, that one's a no. 1.001, no. Negative 4/3, okay? Now that is less than 1, but again, with scale factor, we want to talk about the absolute value, and 4/3 is bigger than 1, so we wouldn't include that. 2/3, that's smaller than 1. 4/5, that's smaller than 1. 9/8, that's bigger, so we wouldn't include that. 0.25, that's smaller. 0.1, that's smaller. Negative 3/4, now that's smaller, but again, we want to check the positive, okay? So even when it's positive and it's 3/4, it's less than 1, so we would include that. Okay, so where might the center of dilation for a given figure lie? Well, it can lie in 3 different spots. It can lie inside the figure, okay? So if the figure is dilated inside one of them, see how the point P here is on the inside, right? Because when we draw our lines through C and B and A and D, the point is there in the inside. Okay, it can also lie outside the figure. So in this case right here, when we draw the line with B and B, C, C, D, D, A, A, the point here, P, is on the outside. And then it can also lie on the figure. So here, if you notice, B and A, they're all on the same line, right? So if we look here, when we draw the lines through A, B, C, and D, the center of dilation actually ends up on the figure. So these are the 3 places where we can end up on for a center of dilation: inside the figure, outside the figure, and on the figure. Okay, our last example says, what must be true about the image of triangle JKL under a dilation with a scale factor of 3/4, okay, so 3/4, that's less than 1, and a center of dilation at point C, so right here. Okay, we want to circle all that apply. Okay, so this one says the image is smaller than the pre-image or the image is bigger than the pre-image. Okay, so here, if our scale factor is 3/4, that's less than 1, the image is going to be smaller than the pre-image. Okay, so this one would not be true. Okay, this one also says the image is on the opposite side of the center of dilation or the image is on the same side of the center of dilation. So remember earlier when we talked about positive and negative, okay, positive numbers and negative numbers, right? We said if the image is on the same side, it's a positive number. If it's on the opposite side, it's a negative number, okay? So our scale factor here is a positive 3/4. Okay, so that means that the image is going to be on the same side of the center of dilation. And that is the end of scale factor and dilations part 1.